In this video, I'm going to talk about utilizing and iterating on the realized flow potential, which is a mathematical calculation which will tell you how fast you are able to go and how fast you're going in your takt plans. Stay with us. So in this video, I want to show you some really cool options. Everybody's going to want to know this information because construction projects get in trouble and we need to have ways to really absorb delays and go faster if we need to, all without hurting trade partners in the process. And so that's what I'm going to show you right now. I hope you're really excited about this. So let me give you a little bit of a background here, okay? In takt planning, everybody already knows that we have time on the top and we have location on the left, okay? In the middle, we have the process, and that process is the trade, together, the trades flowing through the building. So when you see a takt plan, you see these wagons, like let's say that this is zone number 1, and then you'll see the wagons on a stagger, okay? Let's say that this is zone number 2, and that forms a really nice little shape. So let's say that I use the color red and highlight this second wagon is a certain trade, and we colored that wagon red. That right there means that that trade is flowing in the diagonal. And like I show on all of the other videos at LeanTakt, that is the single most important consideration for lean construction scheduling. But what you'll notice here is that there's a shape, okay? So if I was to take this, it's kind of like this little parallelogram, this shape that shows that phase. And what's interesting about every one of these phases, it's really kind of a cool concept, is that every phase on a construction takt plan will have a buffer at the end based on risks, okay? It will have a milestone that it's tied to for that phase, which I really like, so I'll put an M right here. And it will also have your start. And one of the things that I really like to do when interacting with phases in construction, let me write this in purple, is I will pull plan this phase about 3 months ahead. So let me go just do a little milestone here that says pull plan. And about 3 weeks ahead, I will start doing quality meetings for any of the wagons. Now, this creates the framework for our takt planning in construction. It's really quite cool. So in the shape itself, you have this sequence. So I'll just write SEQ. You have over here your line of balance, which is how fast you're going. And then, like I said before, the buffer. So these shapes, these phases, this structure is very intentional and very consistent in the takt planning world. Every phase, whether it's structure or interiors or exterior or whatever the case may be, will have a shape like this, and it'll have a sequence, line of balance, a buffer, a milestone, and then, like what I said before, always a pull plan to vet the sequence and always quality pre-construction meetings to queue up that work. So this structure is like the base in takt planning. It's really, really quite genius. Now, when we create takt plans, we are typically what we'll do is we'll research the drawings and we'll say, okay, if this is my start date in the for the project, this is when design will be done, this is when we'll have a notice to proceed. I will, and I've talked about this in other videos, I will start mapping out and sketching out what the actual structure of the takt plan will look like, okay? So let's say that we have multiple phases. I'll start to sketch this out and say, all right, I think this is what it looks like from the foundations and make ready to the superstructure to the exterior, interiors, closeout and commissioning, site work. And this is when I think we can complete the project. This is when my substantial completion will be, okay? So your macro level takt plan especially will be pieced together with multiple phases, okay? And they will be linked together with what we call interdependence ties. And here's something really cool that I want to show you. Once this is correct, your path of critical flow will move through the building and show through those phases in what's called a critical flow path, or a path of critical flow, but it's comprised of the sequences, so I'll circle that, your line of balance, your buffers, and your milestone, and then any ties that you have to other phases. So this path of critical flow, or your critical flow path, is the real critical path on your project. It's not just some random forward and backward path based on an algorithm. It's not. It's your path of critical flow, your longest path, is really connected through phases. And that's what we have to understand. Now, the reason that this is important is I want you to understand that if you ever have to shorten this, right, your original planning, there's a key way to do it that I'm going to explain now. So let's take a typical phase. So let's say that this is the shape of your phase, and just to make sure that we're on the same page, what that means is, like, let's say hypothetically you have 1, 2, 3, 4 zones, and then this is time on the top. And what I'm saying here with the shape is that you have, let's say, 4 wagons, right? And what this takt plan is looking like is it's looking like this really neat cascade of activities, okay? And that's where your shape is coming from. So just so we're on the same page, your shape is based on the stagger from wagon to wagon and how you finish on that stagger, and the takt time and the number of zones. So if you ever see, let me just say this real quick. If you ever see a long phase, that means that your phase is likely going slow. If you ever see a really like inclined, like semi-vertical one, that means you're going fast. Because as we've talked about before, and this is really genius, I hope you like this, your train is going through the zone. So 1, 2, 3, 4, your train is coming down. Let me get a different marker for this. I imagine time is blue, right? So as your train is coming down through, your takt plan, as time ticks by, right, it's literally depicting where that train was in time. So as we're going through here, your train's coming down, but the reason that it's shown at a diagonal is because it's showing where it was in time. As the train comes down, time is ticking to the left. So that's a ratio. So if you see the distance of a phase be longer in the vertical versus the horizontal, that means the train was going faster than time was ticking by. This one, the train was going slower than time was ticking by. So the shape really indicates how fast the train is going. So here's what I want to explain. On our projects with LeanTakt, we typically, we always say, what is your macro realized flow potential? What then is your norm, and what is your backup? So let me go ahead and pause and talk about what a realized flow potential is for just a second. So I'm not going to get into the math, but basically what it says is, through Little's Law and the calculation that we learned from Marco Biniger and Janos Louis, which is takt wagons plus takt zones minus 1 multiplied by the takt time equals the duration. Using that formula, we're able to look at different scenarios and different speeds for the phase based on how many zones we have. And then you obviously know, because Little's Law says that you will go faster with the smaller batch sizes as you level work and as you finish as you go, you would know that if we went from 4 zones to, like, let's say 6, that this would incline and we would gain buffers here at the end. So hopefully you know that. The realized flow potential is a formula that calculates how fast this phase, or any phase you have, could go based on a 1-day period of time. Meaning that you're not going to split it down below 1 day of time. Now you can, like in manufacturing scenarios, or like let's say you're refurbishing a cruise liner or whatever, you may be in takt times of hours or half days or minutes even. but that's not what the normal realized flow potential is based on for normal construction projects. We base it on 1 day. So the calculation says, all right, you have 4 wagons, you have 4 zones, this is the work that you're doing, the smallest time unit is 1 day. How fast could you possibly go? And it will tell you how many zones you would have to go that fast 100% speed at what takt time. So if you have a 100% realized flow potential, that means you're going the fastest you can go. So let's say that you're not doing anything, that's 0% realized flow potential. Let's say you're going your fastest, that's 100% realized flow potential. That's like the speedometer on a car, slowest speed, fastest speed. So that calculation really gets us into a good spot, okay? Now, whatever realized flow potential you are at, or that you have in your phase, is how fast you're going. If your realized flow potential is 35%, that means if you were in a car and your speedometer was 0 to 100, you're going 35 miles an hour. You could go 100, but you're going 35 miles an hour. If your realized flow potential was 60%, that means you're going 60 miles an hour, but you could go 100. It gives you a ratio or a percentage based on how fast you could go in comparison to how fast you're going. So let me tell you this. Your macro level takt plans will typically be between, and I usually say 35%, but I think I'm going to go between 40 to 50% realized flow potential. And we have calculators for this. In case you're like, no, Jason, I want to see the math. We can do that later. We can do a breakout. I can give you the calculator. But your macro level takt plan is going to be between 40 and 50%. Now, your norm, which is your production level schedule, will be between 50% and 100%, okay? So will your backup, okay? The only thing is that I want this percentage to be here less than this one whenever you calculate it, okay? So this is what this is going to look like. Let me go ahead and show this to you right now. I'm going to pick dark blue. Let's say that you had a project that you wanted to estimate, and you're going to do 4 zones on the left, okay? And you're going to have your overall time, and your macro level takt plan phase looks like that, okay? It looks a little bit longer because it's between that 40 and 50% realized flow potential. Typically, on the macro level, it's going to be close to a 2 to 1 from a shape standpoint, which means that you're going at a conservative speed. So that is your macro level speed. This is the milestone that you promised to the owner. Now, all of you owners out there, you're probably thinking, oh, Jason's trying to underpromise and overdeliver. No, 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 no. Mathematically, if you're between a 40 and 50% realized flow potential, that is a reasonable, fair, and competitive speed. And you can actually go ahead and design your schedules based off of that and still win proposals and still blow your owner like out of the water, like just absolutely impressed, okay? If you then promise this milestone to the owner, there's nothing wrong contractually with them trying to go faster. So let's say that you do your pull plan now with your trade partners, meaning you verify the sequence, and you and your trade partners say, hey, I don't want to do 4 zones for the production schedule, I want to do 6. Then your takt plan phase would look something like this. This would become your norm, okay? What happens here at the end is really critical. This is where you get your buffer. So now you have a speed at your norm level where you're going faster, and you've gained buffers between when you're actually going to finish and the milestone that you promised the owner. Now, here's another key part. I always like to say, well, what is a backup? Maybe you and the trade partners say, well, if we ever get in trouble, we could go to 8 zones, and this is what it would look like, right? I'm just exaggerating this. So this is your backup. You would be able to gain even more buffers in that sequence. So your shapes will be different. So macro, norm, backup, macro, norm, backup. This right here, the macro is going to be 40 to 50% realized flow potential. The norm is going to be 50 to 100. The backup will still be 50 to 100. The key is that this backup strategy will have more zones, typically, than your norm. Okay, so what you'll do is you'll say this, and this is key. Actually, I'm going to write this in a different colored marker because I think this is so important. Your macro, let me write this down, is your promise to the owner. Your norm level is your target. This is what you're attempting to do with your trade partners once you have, and I'll just go ahead and draw this here, once you have that pull plan and you know how many zones that you want here, okay? Your backup, I'll just do BU, is if you get into trouble, meaning that if the owner wants to shorten your duration, or you have a delay, or you have missing material, or something goes wrong, you still have a backup, that zoning strategy where you can go even faster and you can have those buffers and you can finish earlier. Now, let me just say a couple things here. You're probably thinking to yourself, Jay Money, I love this, but you're talking about different schedules. I thought you didn't advocate having different schedules. These are not different schedules. This is the same schedule, the same crew size, the same trade, the same crew composition, the same plan, the same amount of work, the same area, the same everything. The only thing that's different is when you would need materials, because if you're going faster, you obviously need materials sooner. So this does not hurt trade partners. It doesn't. It doesn't hurt trades. And let me ask you this question. Contractually or from a human standpoint, if you said to your owner, hey, we got a really good pace that we've promised you, do you mind if we go faster? Do you think they'd say no? No, of course, yeah, absolutely. As long as the quality's still there, try and go faster. That's what they would say. That's what they would say. This is not three separate schedules. It's the same schedule, different speeds, which your owner wants to do anyway. So I just want you to know that when we're looking at this, these are the same schedule going at different speeds. And again, like I said, this is key. Let's say that you have a material as a part of your macro level sequence. Let's say that there's a takt wagon here that I'll mark as green, and you said that's my date. Well, when you optimize down to your norm, that activity is going to move closer, and if you do a backup, it's going to move closer still. So we do not target the supply chain to connect to the macro level date for the wagon. We target the norm and we add a buffer in the supply chain. So if you have a procurement log, which you should on every job, you need to target your norm level strategy. That's 100%. So the realized flow potential is a formula that tells you between 0 and 100 how fast you're going. We always want to identify a macro, norm, and a backup. We want to make sure that you never get stuck, that you can always adjust your zoning strategy to go faster so that you can still finish at the end on time. These are not separate schedules. They're the same schedule going different speeds. Now, what I want to say here is when you look at the structure, you can verify, this is all verifiable, and we're going to write evaluation criteria if you ever go into a court of law. That'll be out soon. But once you have your phase, you need to always pull plan with the trades, always prepare your work from a quality standpoint. This sequence can be verified with that pull plan. Your line of balance can be verified with this formula. Your buffer can be verified by analyzing how many risks this phase has. So if your owner is ever like, whoa, where did you get these numbers? Where did you get these zoning strategies? Where did you get these percentages? You can always go back and validate the sequence with the pull plan, the line of balance with the calculator, and your buffers based on risks. It is all verifiable. So when you iterate on your takt plans and you are showing an overall strategy, this is what I want to see. Let me go ahead and move this back over. I want to see on every macro level takt plan, I want to see once you've promised, hey, this is the owner's end date, I want to see at each one of these phases a little table that says macro, norm, and BU for backup. And I want it to say, what is your zone strategy and your takt time? And what is your overall duration? And what is your realized, and I'll just write realized flow potential. That way, in the macro level takt plan, I can see what is our base promised, our slowest possible competitive fair speed, and based on these tables, how much farther do we think we can pull it in? Now, some of you will be telling me, hey, Jason, it's not fair to target this and then to finish like 3 months sooner. Hey, that's a fair point, and I agree with you. But what people don't understand is you're going to use up at least 2/3 of that buffer that you gain. You're going to finish earlier, but you're only going to finish by 1 or 2 weeks early or a couple of days. You're going to need this for delays and impacts and variation. Dr. W. Edwards Deming said if human beings understood the statistical likelihood of impacts and variation, they would plan much differently. You have got to have this analysis done at each phase so that you can gain those buffers, so that you can absorb those delays. So this is exactly how you iterate and then show, I might add, your strategies using the calculation, the formula that's called the realized flow potential. It's all based on phases, and I want to see it on every macro level takt plan because it will allow us to have a good overall total project duration and a strategy to gain buffers, and it will allow us to absorb delays. If you need any help with this, let us know. We create macro level takt plans with project teams to get them started. We optimize it. We help them recover from delays all the time. Give us a call. We're ready to go. Put us in. I hope you've enjoyed this video. On we go.